Go with your notes for lesson 2.5. Remember, anything that I write down, you should be writing down in your notes. If I write it in red, we'll call that optional. Lesson 2.5 is going to be about solving equations with variables on both sides. And we'll jump right into doing an example. Here's example 1. 20 plus c is equal to 4c minus 7. Alright, so what's optional? You can see you have a c here, you have a c over there too. They're on opposite sides of the equal sign right now. And that's the difference, or what's new for you compared to doing other stuff. We're going to treat this really the same way. We have this term and this term that are on opposite sides of the equal signs, and they are like terms that we need to get combined. And we were doing this by doing something like adding 7 to both sides, adding 7, so this became 0. Alright, so hopefully you didn't write down what I just did in red. What we're going to do then, in order to get our c's together, let's subtract c from this side. The positive c and the negative c combine to give you 0c, so that would disappear. We have to subtract c from the right side as well. And what we result with here is we'll have 20 on the right side is equal to 3c minus 7. Now we're to the point where this should look familiar to you on how do you solve it from here. We would add 7 to both sides, get 27 equals 3c, and then we would divide both sides by 7. Not by 7, excuse me, by 3, to get an answer of c equals 9. And you don't have to write this down with me. I'm going to redo the problem in another way, just to show you it won't matter which side you collect the variables on, but I do recommend you collect your variables first. If we had decided to go minus 4c from this side, minus 4c from this side, here's where we would get the 0, and on the left we'll have negative 7, and on the right we will have 20 minus 3c. And if we subtract 20 from both sides now to collect our constant terms, over on the right we have negative 3c equals negative 27. If you look, we have the same thing we did there, but we have a negative here and a negative here, so that when we divide we have negative 3c that we're dividing by, and a negative divided by a negative is still a positive 9 for an answer that we get. We get the same answer. Okay, let's move on. And as a second example, I would like to have you guys try this on your own. So after I get it written down, 3 minus 4a equals 5 times the quantity, a minus 3. Why don't you pause the video right now, go through, work this out on your own. If you get stuck, unpause it. But when you get it all finished, unpause it, and I'll go back through working it out. Now that you've unpaused it, your first step should be to distribute this 5 to both things here. Copy things down. 3 minus 4a equals 5a minus 15. Then we need to collect our terms. So if I add 4a and add 4a here, this will disappear. We'll end up with 3 equaling 9a minus 15. And then let me add 15 here, add 15 to this side, so this zeroes out. We'll bring down our 9a here. Over here we'll have 18. Our last step to get rid of multiplying by 9, we're dividing by 9, and a equals 2. And hopefully you guys got that on your own before watching me do it. Last thing I need to go over with you in this lesson is we do have some special cases. I'll give you 2 examples of this. It would be examples 3 and example 4. For example 3, let's do 9z plus 12 equals 9 times z plus 3. You could go ahead and work that out. If you want to, pause it right now and I'll come back and show you that. Or you could wait, pause it after I get example 4 written down here. That's going to be 3 times 2a plus 2 equals 2 times 3a plus 3. If you work those out, I think you might get to the point where you get stuck and something's going to look a little funny to you about doing it. Alright, as far as the solution to these, now the first thing we need to do here is to distribute this. We'll end up with 9z plus 12 equals 9z plus 27. If we collect our terms that have the variable in it, subtract 9z from this side, subtract 9z from this side, you'll notice this zeroes out and so does this. What we really end up with is that 12 equals 27. And 12 does not equal 27, so that's actually a false statement. That 12 equals 27. And if in the end when your variables disappear, and I can do this now that you have a variable on both sides, if you end up with a false statement there, that means that your equation up above has no solution. If you kind of want a better understanding of why it has no solution, we could look at the simplest type thing that would have no solution, and that would be to have something like x equals x plus 1. If you look at that, there is no number that we can put in for x here and here so that the number you have here is equal to the same number with 1 added on. There's no way for that to come out to be equal, so there's no number we could replace the x with. It has no solution. If you come over to example 4, once again we need to distribute here and here. We'll get 6a plus 6 is equal to 6a plus 6. And what I would like you to do is to go one step farther, collect your variable terms on one side, so you have 6a minus 6a. This zeroes out, this zeroes out. We bring down the 6, we bring down the equal sign, we bring down this. This now results in a true statement. And if you ever get a true statement there, this is going to get called the identity. And when you have the identity, it means that every number is a solution. Or anything you ever substitute in for a in this equation up here will come out to make the two sides correct. And another example of this, if you want a quick example, the simplest form of the identity would be to have something like x equals x. Now it won't matter what number we put here for x. If we're putting the same number here, they are going to come out to be equal. And if we now go through and define for you exactly what does the identity mean, that will wrap up our notes for you. And the identity is an equation that is true for all variables. I should say all values of the variable. Whoops, I did not want to do that. We don't want that up. All values of the variable. And what that means actually is the solution to an identity is all real numbers. In other words, any number that's a real number is a solution. And there's a symbol for all real numbers. Put a couple of lines and draw an R through it like that. Alright, that concludes your notes then for lesson 2.5, excuse me.